So this question is about Boyle's law, and it's giving us a bicycle pump, and it explains how the bicycle pump works. You can pause the video and read the question. So the first part is giving us some data and is asking us to calculate the pressure once I have a change in the volume. So we first identify what data were given. So the initial volume will be 80 centimeters cubed, that's V1, and then the initial pressure will be 1.01 times 10 to the power of 5 Pascal. That will be pressure 1, P1. Then is telling us that we are pushed the piston and then the volume decreases to 10. And from the Boyle's law, we know that as the volume gets less, then the pressure increases. So now we're expecting to get a higher value for pressure. So we apply Boyle's law, which is P1V1 equals P2V2. So remember that we need to write the equation. Then second step is to substitute the values. As you can see here, I'm substituting the values. The only unknown term will be P2. Therefore, I need to rearrange this equation and I need to make P2 the subject. So therefore, the value of 10 will move to the other side. If it's multiplication, it will become division. And then this will allow us to calculate P2, which is 8.08 times 10 to the power of 5 pascals. And the second part is asking us to state an assumption. So if you remember, in order for Boyle's law to apply, the temperature has to be constant. We have three quantities that are kind of changing when we have gases, and for the Boyle's law, the temperature has to be constant. So temperature is kind of cancelled out, therefore it's P times V. That has to be a constant. So moving on, when the bicycle pump is used to inflate the tire, the pump becomes hot. Now, what is causing that heat is, of course, the friction. So as you can see here, there's this kind of rubber disc that moves along the cylinder. So since two surfaces move against each other, there's going to be friction. There can be some friction here when the air is going in and out from the valve. This can cause a bit of friction as well. But yes, we mention friction between the rubber discs and the walls. An additional thing to say, like an additional way of getting a mark, is since friction is a force and that kind of piston is moving, then we have work done. And if you remember, work done is the energy transfer from one object to the other. So in this case, the kinetic energy of the piston becomes thermal energy due to friction. So we can approach this question using the work done. And the next part of this question is actually about the work done. So it's telling us about this woman that is using a pump to lift water from the well. State the relationship between work done, force, and distance moved. So we have already mentioned that equation. Remember that it's recommended that you use exactly the words that are given in the question, because sometimes students they try to use the symbols, and if they do something wrong in the symbols, then they will miss the mark. So my recommendation will be to use the words that are given there. And the last part of this question, we have to find the work done. So we are given the mass and we're given the distance. Now, we don't have anything about the force. As you can see here on the equation, we need to find the force. So how can we use the mass to get the force? If you remember, weight equals mass times G. G is the gravitational strength, the strength of gravity, which is always 10. We consider it to be 10. In reality, it's 9.81, but at this level, the IGCSE level, G is considered to be 10. So multiplying the mass with G, that will give me the weight, which is a force. So we have the force of 12.5 newtons, and then we apply the formula for work using the distance that is given, and we see that the work done, the energy transferred, is 109 joules.